Okay, so good afternoon, guys. So we'll continue from where we stopped, right? We're looking at just um, just taking a deep dive into certain concepts in Dart, right? So today we're going to talk about two things. We're going to talk about generics, and then we'll look into concurrency in Dart, right? Generics, and then we'll talk about concurrency in Dart. Okay, uh so let's start. Let me just create a file here in our class 2. Um, Let me call it generics, right? So void create our main function in case we need to write anything. Well, don't really need this argument for now. Okay, so generics, right, in Flutter, just like in many programming languages, right? It allows you to write code that can work with any data type. Allows you to write code that can work with any data type, right? So they basically just generics provide a way to, abstract data types and make your code much more flexible and reusable, right? So it's not tied down to a specific data type, right? At the time you want to use it, right? Any data type can actually just work with it. So they are basically a way to just parameterize your data type. So you can write classes, you can write methods, you can write functions that can work with any data type without specifying the exact type until the code is actually being used. Okay. So the reason we use generics basically for code reusability, because with generics, you can actually write code once and use it with different, data types. And of course, it helps you to reduce duplication. It helps you to reduce duplication of code, right? Yeah, and another thing is type safety, right? Because generics actually allow you to maintain a type safety while you're writing, your code. Okay, so the compiler checks the types at compile time. Okay, so that will reduce the chance of any error during runtime. So let's see an example, right? Let's just say I have let me create a class, right? Let's say I have a class called box, right? So I want this box to have a type. I don't want to say integer, I don't want to say string, I don't want to say any of those things. So I'm just going to use T, right? It could be T, it can be E, right? So this is my class, right? And I'm going to also say, okay, fine. I have a value called T. Okay, and then let me just add that to a constructor. So I'm going to say this dot value, right? Okay. So what are we doing here? So we're using T. So T now represents what? A generic what value type, right? It represents a generic what type. So you can see it represents a generic type. So how can we actually, you know, use this? So for example, my main function, let me create an instance of this box, which is a container. So I could let me just call it box int for integer box. And what does that mean? I'll just say, okay, you know what? This my box. I want to pass in a value. Now remember invalid type. So we need to give it a value. I'm going to give it 10 and close it out. Now I just coded box int, but you can see from the value that I gave based on inference, you can see that my box shows that this actually holds an integer what parameter. So this is actually what an integer. Now, of course, I could also explicitly define this here and I'll still be fine. Okay. So that's actually generics. There's nothing, actually to it. Like I could just print box int, right? But of course, um, um, it's basically just going to show an instance, right? You can see instance of what box with the parameter was integer. But of course, when we did it here, it was what a T. So assuming I could do this, right? And change this to string, right? in as much as I called it box int, but you see that it gives us an instance of what string. So that's actually how generics work, right? Assuming I take this out, I can still run this, okay? And it will still give me string based on what type inference. So the fact that we now passed in a string here, it now means that the box class takes a string, it returns a what? An instance of the box class that holds a string, okay? That's actually, that's basically that about generics. Now you can also have generic methods, right? You can have generic methods like, let's say you have something like, let's say I have a method called get first, right? And I don't know what parameter to give. So I'm just going to say T, and it should be nullable, right? And, it's also T here. And I want to be able to pass in a list of type T. I don't know what it is, right? I'm just making it generic, and it should be a list. So this is a generic function, right? And I could just say, okay, return list dot is not empty, right? So if list dot is not empty, return the first item. But if it is, return null. Okay, so this is a generic what function because I have not specified any data type there, right? So if I want to use this, right? Okay, so what I would just do is to say, let me just create just say let's say the first integer because that's what we want to print out, right? So let's say let me see if I can use this instance. So I'm using this instance to get access to this. So the get first, right, method, it expects a list of something of a particular type. Okay, so I could now pass in a list of integers, let's say 1, 2, and 3, right? So if I'm to print first int, what do you think it would give me? So when we run this, it should give me what? 1. Because we are returning it. First of all, it's checking if the list is not empty. If it's not empty, it will return what's the first item on that list. But if it's empty, it will be null. So what if we just do this, an empty list? That means because the list is empty, it should execute what? Null, which you can see. Okay. My list can actually, I can decide to make it, okay, fine, a list of strings. You understand? And it will still run because now it now takes that, oh, okay, you actually passed in a string here. So that will now what represents the return type. Okay. Of course, you can still explicitly do this, right? Though it's not necessary, but you can still explicitly do this. So when we run this, we should have first. And then this is just the other print statement where you have instance of box string. Okay, so that's basically generics, right? There's no much thing to it. Okay, so let's go into talking about the major thing, right? Which I want to talk about today, and that's concurrency. So I'm just going to create a file, call it concurrency. I don't know if there's any question concerning generics. I think it's pretty much clear. If there's any question, you can just ask on the chat or raise your hand. Okay, Collins, go ahead.
Okay, so my question is about the generics. Sometimes when you're doing OOP, you might want to implement an interface or extend a superclass that is of generic type.
Yeah.
So how do you go about that?
So
Extending or implementing?
if it's hold on, if it's still the same thing as you're extending any other method or whatever, right? Now, but if it's a generic, it just means that you will be the one to decide what type. That's just it. You just have to, like, for example, in what we just did here, right?
Yes.
All I just did was this is just a function, right? Which I could get from some class that maybe is an option and I'm trying to, or maybe I'm overriding this function. But the major thing here is that this function takes in a list of a particular type, which is, this is a generic. So all I just need to do is pass in what I want to pass in. If it's a string, I just pass it in. And by inference, if I don't specify, by inference, it now assumes the type and performs whatever action. So it doesn't matter whether you're getting it from your extending or whatever, it is still a function or a method, right? Which has a generic data type. So you are the one to use that function with whatever type that, your program actually requires.
Oh, okay, okay, okay.
Yeah.
We can go.
Okay. So concurrency. Yeah. So let's talk about concurrency, right? This is where we'll actually get to talk. I'll do some more talking, and we'll write some codes though. So concurrency basically, right? It's a very, very fundamental aspect when it comes to modern software development, right? And it basically just enables applications to perform multiple tasks simultaneously. Okay, that's the concept of concurrency. Okay, now I think this will basically answer, I think someone in the last class, I don't know who talked about isolates, right? This is where we'll actually address it, because all your that code actually runs in isolates, and we'll talk about that. Okay. So but before we talk about that, before we talk about isolates, we need to understand that so let me just mention this, let me just state this out. That code actually runs in isolates. Okay, starting from your default main, which is this your void main, default main isolates, and optionally to expand to whatever subsequent isolates you probably create. And there's what we call spawning a new isolate. We'll talk about that also, right? Such that it's because isolates have their own memory. We'll talk about that. But everything is done in an event in an event loop, which is what I want to talk about first before we go into isolates. That's basically the last thing we'll talk about, right? Now, basically, in Dart, you have what we call an event loop, and your event loop is what makes asynchronous and concurrent programming possible in Dart. I want to believe you've heard about asynchronous programming, but we'll talk about that also. Let's talk about the event loop. Okay, David has a question. David, go ahead.
Oh, bear with me. It's actually not a question. Your screen, a VS Code, is it possible for you to increase the font for the purpose of small screen users?
Okay. Let me do that. Okay. This should be okay. No, let me take. This should be okay.
Yeah, it's better now. Thank you.
Okay. Okay. So yeah. So let's talk about events loop, right? Now that runtime model is based on an event loop, right? So the event loop is actually responsible for executing your program's code, collecting and processing events and a lot more, right? So as your application actually runs, all your events are added to a queue. And we call that an event queue. Okay. All your events are what? Queued up. They're added to a queue called the events queue. And your event can be anything. It can be probably you requesting, to kind of redraw or repaint your UI, responding to a user tab, and keystrokes, or maybe you want to perform some IO task, input output from the file from a disk. Okay. So because your application can't predict what order these events will happen. Okay. So because it can't do that, the event loop now processes the events in the order that they are queued, which is and it's done one at a time. So now an event loop is actually synchronous. Okay. It's synchronous in nature. Okay. And it runs on a single thread. But the thing is this, most Dart applications need to do more than one thing at a time. For example, right, you're building an application that you're getting your what's it called? You're executing a HTTP request, right? So while you're actually listening for that request, while you're waiting for that request, you may also want you may also want to be able to respond to a user tapping a button, right? While you're waiting for that request. Okay, so to handle this issue, this scenario, that's where that has some async APIs like your futures, your streams, your async and awaits, and these APIs are built around this event loop, and we'll talk about them, right? So this leads us to talking about asynchronous programming, right? And basically in asynchronous programming, tasks are executed concurrently, right? And basically this actually allows your application to continue processing while other tasks are waiting for long running operations to complete. So nothing is holding anyone down per se. Things can still go on. The one that needs to take a bit of time to do what it needs to do, okay, no problem, take your time. But other things, you guys can still keep on going. That's the concept of asynchronous word programming. And we achieved in Flutter, we achieved that using features, using streams, and your async and awaits, which I want to believe you guys have used. So basically, asynchronous programming allows you to perform operations concurrently without blocking the main thread, right? And this is very crucial, of course, if you want to build responsive and performance applications, especially when you're dealing with tasks that has to do with network requests, file input output operations, right? Or maybe long running computations. Okay, so that being said, let's talk about features. Now, a feature basically represents a value that may be available in the future. Yeah, it's just I'm using the same word, but it just represents a value that may be available sometime, right? Either with a result or an error. So it's either the value is going to come back with a result, or it will come back with an error. And you actually use features for one-time asynchronous operations. So let's see if we can let's just try to do an example here. So let's say I have a function to fetch a data, right? So we're going to use a feature to do that. So I'm just going to do that by saying feature, because it will return a feature, and a feature will other give you, okay, I need to change my keyboard. This, okay. So void fetch data, right? So now we want to, I'm sure you've seen this, await, and then let me just say, now because it's a future stuff, we can actually delay it. So there's a function or a method, future.delayed, yes. So let's use a duration. Let's just say 2 seconds, right? Now, of course, whenever you're using an await, you must actually use an async, right? That's actually a rule. Both of them go hand in hand. So let's just do something. I want to print, let's print data has been fetched. Okay, so let's run this function and then let's see what happens. So first of all, I want to print fetching data, and then I want to call fetch data. Okay, fetch the data. I want to do some extra stuff after fetch data. Then I want to print data fetched successfully. Okay, so okay, and then, well, we're not using this value. We can take it out or you can leave it, but let's leave it there. Okay, so yeah, so this is an example of how we use a feature, right? This is an example of how we use a feature. So, well, after fetching the data, so let me add one more print statement here. After fetching the data. So we are done with that. So let's say to the next task. Okay. Let's just do this so we understand. So basically in this example, I'm basically just simulating how to fetch data from a network. So what happens is that the program will continue with other tasks while it is waiting for this data to be fetched. So let's run this, right? And let's see what we have. So you can see, now look at the order in which this was actually done. So first of all, we got, of course, we're running the main function. So this will go first. So it ran fetching data, and then it went into this method, right? And because this is a future, and we are kind of doing a 2 seconds delay, but this is a future. So it actually would wait on while these ones are, while it is actually getting its data and everything. You can see it just came and ran this one, which is to the next task. And then when it was done, it now gave us the results, right? First of all, we had this print statement here. So when this was done, when it was done fetching, right, whatever function, because this can be anything, right? This can be anything. It can be your actual code to fetch data, right? It can be you want to perform an operation and return a value, right? So, but we await it. We await it. And then it prints this data has been fetched before it now prints this one. Data fetched successfully. Okay, so that's basically what asynchronous programming, and that's future. So you see, it ran this, and then while it was still running this one, it didn't wait for this guy. It just actually went down to this other one. And then when this was ready, right, then it printed out the result. Okay, so that's actually future, right? It's actually straightforward. Now let's talk about async and await. Let's understand async and await. Now the async and await, they're actually keywords in Dart. Okay, let me bring this down a bit. So they're actually keywords in Dart. Okay, okay. Don't want to kill it. Let's just leave it. So they're actually keywords in Dart, right? Now, they basically provide a syntax that they make your asynchronous code actually look like or behave like a synchronous code. And it actually helps you to it makes your this thing actually readable. So let's look at how they work. Right? I'll also give another example, but let's use this example. Let's look at how they work. Now, when you mark a function, right? When you mark a function with the async keyword, basically what it does, that it allows you to use the async keyword allows you to use the await keyword inside that function. So let's take note of that. That's why you can't use await without async. So the async keyword allows you to use the await keyword inside the function. Now, an async keyword always returns a future. It always returns a future. Okay. And another thing to note about async keyword is that, that executes the code inside the async function asynchronously, meaning that it doesn't block the execution of other things. That's why you're able to see fetch data, and then you now sort to the next task before you saw these other things. All right. So that does not block any code that's inside this async function. Okay, it runs it asynchronously, so it can execute other things while it is doing this. Okay, so that's for async. Now the await keyword, right? Now, of course, first of all, you can only use the await keyword inside an async function. That's one. Now, what await keyword does is that it suspends the execution of this async function, which is this fetch data, right? This fetch data is an async function. So it suspends the execution of the async function until the awaited operation completes and returns a result. So until whatever, in this case, we're just doing a delay here, right? Until whatever this is awaiting for returns a result or a null, because the result is either actual, it's either a result or it's return an error, right? So until it returns, right, it suspends this what. That's why when you call this function, it didn't actually execute immediately. So the await what holds it down until this is done. Once this is done, it now what executed this function, because you can see part of the execution of this function is that there should be a print statement that says data has been fetched. But it held that down until it got a result from this. After getting a result, then it what allowed the what function to be what run, to be executed. Okay. Another thing to note about the await keyword is that it must be a future. The operation must be a future for you to be able to use the await keyword. Okay. The awaited operation rather must be a future. That's why we have this future here. And then when you're using await on a future, okay, if you're using it well, you should know that it should pause the execution of the current async function until that future completes. So, and after that, it will now resume, the result. Is to resume with the result of that future after it's done. So, that's basically that. So let's look at, assuming I want to create another function, right? So I fetched the data. Let's say I want to create another function, a future. Let's say process data. And of course, it should be an async because we're going to use await. So, but before then, I want to print fetching data. Right? So let's do something. I'm going to say string. Let's get a result is equals to await. And then I want to call fetched data. Right? So let's see. To try something. So this has a type of void and can't be used. So yes, so our function does not return, it returns void, but here we can't pass voids to a string. So I'll just change this to, so let's assume this our function was returning a string. So because it's returning a string, I'm going to just we need to use a return statement. So I'm going to return let's say data fetched. Okay. So yeah, so we'll get that to store it in results. Then I want to print results. And after that, I also want to now print data processed. Okay, so let's look at this. Let's look at this example, right? Let's look at this example. So to use this, let me just take this out now. So I'll just call processed data, right? That's all I just need to do. But let me also do a print statement. The essence of this print statement that I'm doing is so you actually understand how this asynchronous programming stuff for concurrency is done, and know how the order in which stuff is actually being tasks or are being executed. So continue. Okay, so let's run this and let's see what we have. Let's run this. So you can see the delay after continuing with other tasks. So first things first, what did it print? Fetching what data, which is what this. We called the processed data. So the first thing it did was to print this, right? Now, immediately printed this. Now, of course, the next thing is to execute this. But remember, it is awaiting this. So because we're using this await, it's not going to stop these other words, what's it called? Executions. It's not going to stop these executions. Not this one rather, because this one is dependent on the result, which is also dependent on this. So what did it now do? So look at the order. After printing this, we now came to await this, right? We came to this point. So it needs to get run this fetch data, which is also a future, right? But because all these things may take a bit of while, what did it do? It came here after this, and it just printed continuing with other tasks. And probably after it was now done, first of all, it now returned this data fetched, right? Meaning that we now have a result, right? And then it printed the result, and then it printed data processed. Okay. So is there any question at this point before I move forward?
No question from me.
Okay. Okay. So that's good. That's why you're intermediates. Okay. So that's actually that on what's it called? Async and await, right? So let's just touch streams. So basically, right, streams are just a sequence of asynchronous events. Okay, Collins, your hand is raised. Go ahead. Samuel, why were you laughing?
Okay, sorry. I get the features on async and await, but I just have like a kind of practical question. I might
Okay.
give a use case. Okay, my question is like this. I know asynchronous codes they execute asynchronous. Like that's if there's another code down the line and the feature is not being awaited, it will move, the execution will move down. But
Yeah.
then I found myself like, let me just give this use case now. There was time I was coding and I was using a singleton design pattern for a resource. That's a system resource. And
Okay.
I didn't want many asynchronous code calling it multiple times at the same time. You get, so, and I had to limit the calls to it such that only one can use that resource at a particular time. So what I did was I queued up all the calls and executed them one by one. But then, like, my question is, most times I don't know how um to programmatically complete a feature. Do you get what I'm asking? I want to like,
Go ahead. Go ahead.
okay, let's say someone makes a call to that resource. I want to return a feature that will complete when the person's call has been processed, because maybe their call was like in front of the person's calls that need to be processed before the person's on. So, but like, I want to return a feature that will be completed when that call to that resource has been processed and completed. So like, I want to programmatically complete the feature I'm returning to that person. Like,
Okay.
do you get
So
what I'm
if I'm
asking?
to if I'm to get what you're saying, but so this is it, right? Um, one of the major things that will help you is, first of all, understanding what's it called? Time complexity to complete a particular task, right? And sometimes that's one thing we don't really consider when writing codes. You may have written a code that works, but the question is, how much time does it take for it to for it to actually work? So, but that's just on a different note. So if you consciously, because the thing is this, right? When you, based on the concept of asynchronous, right? No, nothing, it
Mm,
does not block the main thread. So if you have this particular action that needs to be done asynchronously, and it's, of course, it has to wait. If there is a task down the line, it's, while it is waiting for this, it will go ahead and do this other thing. But in a case where you don't want to, right, you can also try to delay certain things. You can delay a
okay.
particular task from going on, from processing, right?
I
So
do.
that's one way you can actually do it. It all depends on what you want to achieve and the order you would want to actually achieve it, right? But that's one thing you should
Mm,
just, that's one. I don't really, and I don't know where we'll have all the time. Maybe in the course of our classes, we can maybe practicalize it, right? And then we'll
oh,
get to
okay.
see, yeah, we can practicalize it as, just keep this, what's it called? This your scenario, right? We'll find a way to actually do a practical stuff, and probably I will use that to teach us time complexities when it comes to programming.
Okay. Okay.
Yeah, but delaying certain tasks may actually just help you. It just may, especially, like I said, I don't know how which one should go after this one, or this one should go after this one, and all those stuff like that. It's so, but let's see how we can practicalize it as we
I,
go
I
along.
sorry, I want to ask you, can I like post my code on the Flutter Intermediate group
What
to
code
see
are you
to see
posting?
like to see like the use case and where the problem is at?
Okay, okay. You can post some.
Okay, maybe after the class I'll do that. Thank you.
Okay, yeah. Okay. So I remember somewhere he used a laugh emoji. I wonder what that was about. Was it because I said you guys are intermediate now? Okay, so let's move on. We're talking about streams now. Yeah, talking about streams. So like I said, streams is just a sequence of asynchronous events. Okay, you can actually use it to kind of for continuous data streams like user inputs or real-time updates, right? So let's see if I can just come up with an example. So let's see. So you can see a stream. So it provides a way to receive a sequence of what events, and each event is a data event, also called an element of the stream, or an error event, which is a notification that something actually was failed. So let's see. It actually uses, so you can actually produce a stream by calling the async, but this one has an asterisk function, which then returns a stream. So let's see. I have a stream, and let me give it a type of integers. Integer. So the name of the stream, I'm going to call it counter, a counter stream. Okay, so we use this the async with an asterisk, and good. So I just want to say just a simple count stuff. So for int I equals 0, sorry, let's just use a small number so we don't have I less than 5, and then of course we have to increment I. Right? So for this condition, right, await, and then let's just do a future.delayed. Duration of let's just use 1 second. Okay. So, and then when you have put your what's it called? Your whatever it is you are waiting for, we now use a yield. So what we want to yield is what I, okay? We now put what a yield. So just think of it like, okay, you're now returning I. So how can we use this? So let me just comment this out. Okay, so I'll just call my counter stream, right? And then what we now do whenever we're working stream, so you have to listen, right? We listen to what an event. So dot listen. So we listen to an what event, okay? So what do I want to do with this event I'm listening to? For now, I just want to print it. So let me say counter event. So that's just all I want to do, right? So let's run this, and then, so remember, it's just giving us, this function is just giving us 1, 2, 3, 4, 5, but you can see it's delaying after 1 second, right? So await this, right? But it's delaying after what, 1 second. So if I make changes to 2 and run this again, so we have counter, 0. After 2 seconds, the next one, 2 seconds, so it's 3 seconds. So we are listening for that what stream, right? So that's actually that's basically about streams. That's basically what streams that's what streams are, right? So yeah, that's basically that. Okay, so let's round off by talking about the actual thing that I think it was Collins that asked that question. Collins, you're the one that asked about isolate, right?
Yes, I am.
Okay, so let's round up by talking about isolates. So let me just create a separate file for isolates, right? Sorry, isolates dot start. Okay, let me keep my main function handy. Okay, so let's talk about isolates, right? Actually, in that, isolates basically provide a way to achieve concurrency. Okay, and what it does that by allowing multiple units of code to execute independently and concurrently, but without sharing memory. Very important. So each isolate has its own memory heap that actually ensures that the data is isolated, right? So an isolate, right, is basically just a separate instance of the Dart runtime. Okay, an isolate is a separate instance of the Dart runtime that runs on its own memory. Okay, it runs on its own memory space. It runs on its own memory space. So think of it like a lightweight thread, okay? But it actually doesn't share memory with other isolates. So another thing about isolates is that they can communicate with each other, right? So let's write a bit of code, right? I'm going to just create a simple function here, just above this. So let me say void full, and just have a var, a parameter var message, right? So I just want to print, okay, let me just print isolate received. And then I'll just pass in the message. Okay, so I'm going to create another function to an add function, right? Basically just to add two numbers, right? Let me just create it in the most simplest of forms, right? I'm just going to do that. Yep, so this will be num2, and then sum, which is basically num1 plus num2. Okay, no, they've shorter way to write this, but let's just do it that way. Okay, so before I run this, right, we've talked about isolates, right? And another thing is that isolates can communicate with each other, right? And they actually do that. Isolates communicate with each other using asynchronous message passing. Basically, what that means is that one isolate sends a message to another isolate, and the receiving isolate processes that message when it is received. So messages can be any serialized data type. It could be primitives, it could be your lists, it could be your maps, it could even be custom objects. Okay, and that's actually a concept of isolates communication. There's also what we call spawn, SPAWN. Now, isolates are created using the isolate spawn function. We're going to actually use that now. And basically what that does is that it takes a function as an argument. So your function now is now the entry point for the code that will be run in the isolate. So, okay, enough of talking. So let's just test the fun out. So I'm going to write, let's call our isolate function. So I'm going to say isolate, you can see it here, right? All that goes right in isolate, and code can access classes and values only from the same isolate. And of course, different isolates can communicate by sending values through ports, send port, receive ports. We're going to demo that. So basically, you can see here that it's actually an object, right? An isolate object is a reference to an isolate, which is what I want to do here. So I'll just say isolates.spawn. Okay, so isolate, so I need to import it, .spawn. So for this message, right, I'm just going to, let's not use this. I'm just going to, so the spawn here expects this. So I'm just going to say, I'll pass in full, it expects a function. You can see that it expects what a function, right? And then a message. So I already created the function here, which is this foo, right? So I'm going to pass that and then a message. So the message there, I'll just say, hi, isolate. Good to see you. Okay. Now, after doing that, I'll call this add function. So let's see what's going to happen here, right? So I'm going to run this. So you can see isolate what received. Okay. Hi, isolate, good to see you. And then it still passes the word what's then. So this, let me run that again and show you something. So both of them, this actually runs on a different word thread. Okay. It has its own memory and that. So that's why you can see that two of them actually, it's like they just executed the same time, right? Like almost the same time, okay? Because we are not waiting for one to do the other or anything. So anyone that wants to, they are just running, they are running separately, right? So it depends on which one actually comes first, right? Which one executes first. So if you check the first time, you can see we had isolate received, and then 10 was printed. When we run it again, 10 came first, isolate received came next, right? So let's run it again, right? You can see isolate received came first, and then 10, the other way, right? That's actually just about, that's using this spawn, right? Now, for the sending of messages, right? So we use send port to send messages to another isolate. And then the receive port is used to receive messages from another isolate, right? So let's actually test that. Assuming I want to create a function called isolates. Let's just call it isolate entry point. And then we need a send port, right? So I'm just going to call we need a send point instance of variable, right? And then I'm now going to say send port dot send. So I want to send a message. I'll just say this is isolate, right? Now, in my main function, what I can now do, I'm just going to, let me comment this out, right? I can receive this message now by using the receive port. So I'm going to create an instance of the receive port, right? Okay, and then first of all, I'm going to, let me spawn device, right? Basically, I could just do it this way. Await. Now, the fact that I want to use await, meaning that I have to what use as, okay? So I'll say await isolate dot spawn, right? And then of course it takes a function and a message. So I want my function to, I created entry point. So this one sends a message, right? And then here, I'm going to receive the message, right? So I just created an isolate, okay? It runs on its own, right? So what does it spawn out? We have the function, right? This is going to send the port, and then the receive port dot send port. So now let's, so how do we now listen for messages, right? How do we listen for messages? So how I'm going to do that, so let's listen for messages from another isolate, okay? Now, I'm going to use my receive port dot listen. It has a dot listen method, right? Right, which listens for events, right? So dot listen, and what does it also listen for? It listens, you need to pass in a message. So here, I'm just going to print received message from first, okay, from an isolate, let's just, right? And then I'm going to pass the message. Okay, yeah. Of course, so after you receive, you have to close the port when you're done. So we have the receive port dot close. We have the receive port dot close. Yeah, I think that's that. So let's run this. Let's run this. Okay. Okay, so we have running. So I think so. Let's look at what we have here. So receive port, okay, and then this. So we have our isolate. So receive port. Okay, so it's not printing anything. So we are probably missing out something. So let me see. Okay, so this is it's okay, so this is to listen for the messages. Okay, so let me get something. Okay, so these are a few things you can do for an what's it called, on an isolate, right? These are things you can do on an isolate. You can resume, you can remove, you can pause, you can ping, you can convert to string, of course. Your so you can control the ports. So the isolate object allows you to send control messages through a port, right? It helps you to send control messages through port. So, okay, a hand is raised. David, go ahead.
Oh,
You
thank
have
you
your
so
hand
far.
raised.
I just have just one question. Like, what is the real life application for isolate most likely? Is there a situation where this is usually used? Because I know that when it comes to endpoints calling, more like your API calls and the likes of it, we usually use fusions and async and await. So, but isolate, what are the, do you have an example of the proper situation or application built where this is best used? Did you get
Okay,
it?
so this is it. Yes, yes. Don't worry, I got your question. Now, the thing is this, right? When one thing about programming, right? Any process can actually take longer than it should to complete, right? One of the possible uses of, or for one of the most commonly used scenarios, right, for isolates is when you're reading data from a local database, right? When you're reading data from a local database, because like I said, any process can take longer to complete, which is dependent on, the implementation and the input data, right? So you don't really know, like that makes it impossible to create like an exhaustive list of when you should consider whether you should use isolate or not. But one commonly used this thing scenario for that is when you want to read data from a database. Okay, so yeah, I don't know if that answers your question. So I think maybe one of the major thing you're trying to know is if we are going to use it, if we're ever going to use it in this, in the course of this training. Is that one of the things you want to know?
Yeah, possibly. So
Yeah, well, the thing is, yes, of course. See, like I
just
said,
to build
these
my design thinking actually though. So just to
yes, yes, yes. So the thing
know
is,
what.
yes, we should, or we will. Like I said, in the end, it's all about like, okay, fine, we'll implement when we have to, we'll probably have to work out a, what's it called? A scenario where we have to read from a local database, and then we'll now make use of isolates in that area. I don't know if that actually helps.
It's okay. It's okay.
Okay. So does anybody have any other question? Does anybody have any other question?
Yeah, I do.
Okay, yeah, go ahead.
What about these streams? Like, which scenario can we use like a stream for?
Oh,
Because I know like
we
people use
seems we
more of
are
async and await.
so it seems we are on a when are we going to use stuff in I think that's the question we are now going on. When are we going to use where are we going to use streams? Okay, so first of all, what are streams, right? We said, when you have series of this thing, stuff you want to emit, sequence of data events and likes, right? So the question I would even want to ask you is, what is an example of a sequence of data events? I think that's even the first thing, because I think what we now need to, from the question you're asking and the question that somebody else is still, going to ask is, when are we going to use what scenario and all the stuff, right? Now, but another question, one of the things that will help you is this. First of all, what are you trying to do? Right? What are you trying to do? And when you know what you're trying to do, then you now have to ask yourself, what is the best approach to it? Yes, many persons use async and await, and yeah, that's not a big deal, right? But there are certain situations that you have to figure out based on what you are working on, right? Based on what you are working on. Like from the example we used, right? We were trying to just await this. And basically what this was basically just doing, well, see, what we're basically just doing here is that we are awaiting this time, right? This implementation to what carry out this what function or this instruction to what give us a count, right? So for example, you can use this for a timer. Let's say your application actually has a timer, right? Where you have to be doing all those stuff, right? And understanding now, another thing is this. So this is where isolate comes in too. Now, knowing that isolates run on a separate, thread, they have their own memory and all those stuff, right? What if, let's say, for example, I'm just trying to paint a scenario here. Your timer, you want that to nothing. Remember, these things about threads, we don't want anything blocking each other, right? We don't want anything blocking each other. We're also trying to do memory management and all those stuff. So, okay, you know what? And my timer just run on a separate thread, regardless of whatever screen or wherever, can it just run on a separate so that nothing actually causes any delay, nothing blocks it, or, whatever. Can that actually what happen? Okay, so these are designed decisions based on what exactly you are working on. Yes, there may just be a simpler way to do it. Okay, fine, just use your what's it called? Use your async and await, right? Just use your async and await and just chill. Don't stress yourself. Yes, that can actually work, but if using an isolate, that's why we're actually kind of getting into these things, right? Of course, from a beginner level, yeah, you can just do, there are certain things you can actually, in fact, currently, there are certain ways you build your UI as a beginner. We will not build it in an intermediate level that way. Not because it will not work, but it is just when you now consider performance, right? You consider memory management, you consider memory leaks and certain things, you now know that, you know what, in as much as this will work, right? In as much as this will work here, no, but if I want to consider performance on the application and all those stuff, I think I just need to use this other method, right? So Yeah, I think that's basically that. I think that's basically that. I don't know if that's in a way answers your question. And maybe any question that will come regarding when to use a particular thing, right? Um, Even the example, even me telling you that you can use it for reading from to read from local database, right? Doesn't mean you cannot just do it in another way. You understand? So, but like I said, sometimes when you're now thinking of performance optimization, memory management and all those stuff, you now know that, oh, ah, because your user does not, whoever you're building that product for, app or whatever, they don't know threads. Their one is I install it, it should be fast. When I click this, why is it that whenever I launch the app, whenever I click on profile picture, this thing is taking a lot of time? Maybe the way it was developed, everything is just running on the main thread, right? There's what we call deadlock, right? Sometimes one of the reasons phone hangs and all those stuff or apps hang is because of what, um, you know, limited resources. So two, three, four, five things, just like this guy gave hints the other time, fighting for one resource, right? They're fighting for just one resource. So in cases like that, of course, there will definitely be the performance of that this thing will be program or instruction will be affected. Okay. Yeah. Is there any other question? Any other question?
Can you hear me, please?
Yes.
So I wanted to ask, like, I really don't have, I'm not really confident, like, should I say confident consuming APIs yet? So I still have like a little bit of pull around with that. I don't know if we're going to be touching that as well.
We will consume APIs, that's for sure. We'll consume. You eat enough of you eat APIs. Especially if you make it to the final stage, right? Where you work on a capstone project, right? Of course, you will work with APIs. You can't finish intermediate level and not actually, um, you know, work with APIs now. That would be a big blow to my face and to the face of CodeCamp. So yeah, that's basically that. Any uh any other question? Let's just take questions. Any other question?
Sorry, Collins, it's Collins. I
Yes.
forgot to raise my hand. I have a question.
Yes, go ahead.
Um, to, with the streams, what happens to the stream when you don't listen to it? Does the code inside it still run?
Yes, it will run. You're just the one that is not listening.
Okay.
Yeah, you're
Okay.
just the one not listening to it. So listening means, oh, somebody is saying
But
something.
but, but
I want to get the message. That's listening.
okay, but then at the time where I start listening to it, will I
Okay.
still get the first data that was emitted from the stream, or just at the current state it is now?
Okay, so that depends, right? That depends on a lot of things, right? Depends on a lot of things. If whatever you're listening to is just um emitting one information, like one data, right? If it's just one, that's fine. But if it's streams of something, like if it's like a running stuff, of course, you're going to meet the current state. So just think of it like
Oh,
maybe you're trying to you're listening for a
mm,
uh a change. You're listening, okay,
mm,
there's a list of information dropping and you want to
yes.
listen for it. At the time when you connect to start listening, if that information has, it's a stream, so it's moving. So at the
Yes.
point where you listen for, you pick up from where, except you can, of course, I think, yeah, that's a very interesting one. You can try that out. But of course, it all depends on what is being listened to or listened for, if I'm to use that.
Okay. Because I feel
It's
like most
possible.
times when sorry,
Yeah, go
I
ahead.
feel like most times when I want to download, like, let's say a very large file from the internet, I'm not going to load them all at once. I might use stream to listen for the bytes, like let's say blocks of bytes individually. So like let's say I started the stream at some point in my code, and maybe say I'm in another screen or widget, and I want to start listening for those bytes. Like, before the person moves from one screen to another to click, have I lost the bytes already?
No,
Or
I
do you
think
get what I'm saying?
you just like, have you used, talking about download, have you used Internet Download Manager?
Yeah, I think I might have used software
So
like that, not
well,
necessarily the
you
particular
can
one.
check it out. That will even just show you what. So the thing about Internet Download Manager is when, for example, if you want to download something of like 500 MB or 1
Mm,
gig, what
mm,
it does not download everything. It takes it
mm,
in little chunks, right? Like a so
okay.
so it's more like bringing in like a stream of there. So wherever you stop, right? Maybe you
Mm,
got disconnected or whatever. When you reconnect, it continues from there. It continues from there
okay.
where you stopped to what. After it's done, then it now, so 500 MB, you can decide to take it 10 MB, 10 MB, 10 MB. It doesn't take it small,
Yeah.
small 5 MB. When it's done, it now brings it together. That's how Internet Download Manager works. So,
Okay.
like I said,
And
everything depends on configuration, right? If it is
okay.
configured, if what is being configured on the back end that you're listening to is something that is
Yeah.
just moving, right? You pick up from wherever you get. It is when you start listening that you get information. So think of it like radio. When you tune into a radio
Oh.
to listen, whatever was said before has passed, right? But there's
But that's very sorry.
also
That's very inconvenient.
there's also a Netflix implementation, right? Where you're watching a movie, right? You can
Yeah.
just come back to a particular, you can pause, right? And then when you come
But
back
I
to,
would like
yeah, go
the
ahead.
thing is I would like my stream to start when I start listening to it. Like I don't want it to just start on its own. You get. And
Uh,
sorry.
Go ahead.
Lastly, sorry. In this code now that I'm seeing in the screen, what happens when you listen to this stream two times? Like attach two listeners or three listeners. Like are the three of them gonna get the events at the same time, or
Sorry,
like
what do you mean
could
by
you like
attach three listeners? How?
in this code where you wrote in this code where you wrote counter stream, you called it, then you added dot listen. Then
Okay.
that closure inside there is kind of a listener. What happens when you
Okay.
call counter stream dot listen again with another closure and
Can
counter
you
stream dot
imagine?
listen
You
with
want to
another closure?
you want to do a recursive counter stream. Okay, I like the way you think. So this is what you're saying, right?
No, not inside the closure, like outside, inside the main function, inside the main
Okay, like
function.
so basically, is this what you're
Yes,
saying?
exactly. But then process it another way. Maybe say print counter listening
Okay, count.
two
Okay,
times or whatever.
let's say new counter, right? Something
Exactly.
like this.
And maybe
Okay,
a third one, then run it.
okay, a third one. Okay, and okay, so let's just call this counter one, and let's call this counter two, and then let's call this counter three. Okay, so let's run this. Okay, so you can see what's happening. So three of them, remember, they are
Yeah.
running this concurrency. So you can see three of them listens. The next one,
Yeah.
so
Okay.
it doesn't matter, right? So there's no order as okay, this one will do it first, and then this other one will do it second.
Okay. Okay.
It's calling all of them. That's the thing about stream. So you're just listening. So three of them are listening at the same time. So they are getting the information too at the same time.
Oh, okay. Thank you very much.
Yeah. Okay. So is there any other question? Any other question? So that's basically that. So next week we're going to go into we'll first of all look at we'll go into Flutter, right? The first thing we'll look at is and I want you to come with, in fact, let me tell you what we're going to work on so that you go and do your research, and then let's come and do small arguments. We don't really like arguments, constructive stuff, right? Discussion. So we're going to look at, first of all, we'll start with talking about folder structure, right? How should you really arrange your folder when you're working on your project? So we'll start with that. on Monday, and I'm sure we'll be able to finish that because it's not really that long, but we'll also do some practical stuff. And then, but the major thing we're going to be doing for the next 2 weeks, if not 3, because it is very important, is testing. How many of you have actually done testing? Is there anybody
I've
here?
not done that. No.
I've not
Who
even
get time?
tried it before.
Who get time for that one? Who get time for that one? I never finished building a test I could think of.
You guys are not serious. Yes, that is one aspect that a lot of developers run away from, right? And it is very important, right? I used to be there. I used to run away from testing too, right? In fact, the testing we do is that we just write the code and then we just run it on the app and then we just test it and we move on with our life, right? So, but we're going to look at testing. Of course, we have unit testing, integration testing, widget testing in Flutter. So we're going to look at testing in Flutter, right? There's a lot packed for you guys, right? There's a lot packed up for you guys. We're also going to look at CI/CD. We're going to look at automations, right? Learn how to use workflows and write tests with GitHub Actions and some of those stuff, right? As much as we'll build applications. So we'll look at testing next week, right? As well as the page folder structure. Now, the reason I'm doing that is because I need you guys to learn a particular process when you want to start working on your code, right? So we'll learn testing. I believe all of you have GitHub accounts, right? We'll learn testing and we'll also learn GitHub Actions such that you're able to write tests on your code that also will be automated, right? When you push your code to GitHub, a test should actually run, because sometimes we write code and we forget to follow certain syntax rules, right? Just because you don't throw an error doesn't mean you're following the best practice. But tests can help you to make sure that you would stick to it, right? So next week is going to really, really be, for the next 2 weeks, right? If not 3, yeah, our hand is going to be filled with hands-on stuff, right? So I need you to get ready, get set. We have a lot of work to do. If you don't have a GitHub account, of course, I believe you should have, right? Set it up, make sure it's connected to your VS Code, so that we can implement pushing of code and all those stuff, and based on our tests. So yeah, I think this is where we're going to round it up. I want to say a big thank you for every one of you that joined, and we will meet next week. But before then, I'm going to drop something. Okay, David, you have a question, but I'm going to drop a task for you. Yes. For some of you that don't know, in KodeCamp, we give tasks. I'll drop a task for you that you will actually hit over the weekend. Okay, David, go ahead.
Okay, so my question is, do you want us to create a separate repository on our GitHub, or how is it going to be? Is there a modality for the purpose of this bootcamp in terms of your GitHub?
Okay, so the thing is, you're going to use your GitHub, right? You're going to use your GitHub. The repositories that you create is with respect to whatever it is we are working on. Okay, so but and the way we're going to do it is we're going to have repositories for certain we'll get to a point where we may actually have to build certain things, and they will have to be in separate repositories so that you also have a repository that explains a particular concept or carries out a particular concept. So in other words, it's per demand. Repositories is per demand, right? Once there's a demand for a particular repository to be created, then it will be communicated to you, okay?
Okay, that's clear. Thank you.
And then is there anybody here that doesn't understand who GitHub? Is anybody here? If I shouldn't even ask that question. You're intermediates, so I shouldn't ask that question. But once we start making use of GitHub, pushing and pulling and all those stuff, when I think I hinted at this, when I want to communicate, maybe you write something, I need to review your code, right? I'm not going to come on Discord to tell you anything. I will just make a comment on your GitHub and you should get a mail and you respond there. The essence of that is to teach you best practice, is to teach you industrial practice and standard, right? Because for some of you, when you start working for that big company, right, is serious in a serious tech space. When you push a code and the person that is reviewing it, they'll drop a comment there. They won't call you on the phone and say, yeah, Collins, is that you? Okay, thank you. On your code, okay, your code is not running in this part of the code. No. Don't just drop a comment. What is this? Okay, do this, don't do this. You should be able to go there, fix it, resolve that comment. So we'll follow certain industry practices that you need to start getting used to if you are not already used to it. Okay, so thank you very much, guys, and let's have a wonderful weekend ahead. Thank you.
Thank you. It's nice meeting you. Bye-bye.
Bye-bye.